Yep.
For derivatives of f of x, if we're not going to write f prime of x, can we write d of dx? Exactly
Yep.
correct.
Yep. Okay, so first question was like, if we don't want to write f prime of x, hello? If we don't want to write f prime of x, can we write that? Yep. So to write the equation of a tangent line, I need a point and a slope. Finding the derivative finds which thing? Slope. So what is the derivative of that? It's gross?
It's not
All
terrible.
right, Daniel, what is it?
3 to the power of 2x times ln 3 times 2.
So derivative of e to the stuff is e to the stuff times the derivative of stuff. This isn't e, it's 3. So 3 to the stuff is 3 to the stuff times derivative of stuff, and then you got to pay the exchange rate. Wasn't e, so we need that natural log of 3. Okay, so I need now a coordinate. F of 1 looks like 9. F prime of 1 looks like yuck. 2 ln 3 times 9, so 18 ln 3. So the equation of the line is y minus the y value equals slope times x minus the x value. Did anyone do something different? The irritating thing with logs, it can look really, really different. First thing I thought of was, why do I need 3 to 2x? Why don't I just make it 9 to the x? Then f prime of x is 9 to the x times change of base. There was no chain rule involved. There's my natural log of 9, like just so you see that these come out to be the same. F of 1 is still 9. F prime of 1, I get something that looks different. If I make this 9 times 2 and put the 2 in here, I get the same thing, but it takes some mushing around. So this, when we have trig stuff and we have log stuff, just a warning that if it's multiple choice, their answers can look different. Yeah.
So if it's like not multiple choice, do you care like which form?
If it's free response, if it is valid, it's good.
Like,
And
okay.
and I'm an AP grader, and it's irritating how creative you guys are. It's like, yep, tricky, you got me, and it's true. Like, yours is right. You are all very, very creative. I grade hundreds of the same question. I've done AP grading for 6 years now. I've seen maybe 12 different questions. Like 1,200 of one particular one. Happy to never see that one again. All right, so before showing you the thing we were supposed to do today, did you guys have questions from yesterday's homework? Yeah.
Like some of them like had a restriction, but like some of them didn't have it. So I was like, in what cases do you need a restriction versus not? Like I know it has to do with divine by zero, but like some of them felt like I wasn't exactly sure whether you needed it or not.
So this was the homework. I mean, I don't see what, oh, you mean in the answers it said there were restrictions?
Yeah.
Okay. If in the end, like, the domain of your derivative can get smaller. And in general, I'm not going to ask that. I'm not going to say I don't care about that, but I'm not going to ask. So, what's my answer? Yeah, I don't care. Like, here, there are restrictions already on this one. X can't be 0 or negative, because natural log, you can't do natural log of anything 0 or negative. So, and here, I can put in negative 1.999, I can't put in negative 2.
So would you need to write the restriction out, like in the answer?
No. And even on AP, they'll be like, but you knew that that was a restriction when we started. Whether you did or not. Okay, those of you who did the homework, yeah,
43.
43. Most people ask about 41 first. 43 was not assigned yet, I didn't think. That was supposed to be for tonight's homework.
Oh, it was,
So,
really?
it was? Okay, so you guys were not able to do those 3 yet. So we will get to them. But I wanna look at 41. Because it's involved. So they're asking you to find the equation of a tangent line that's tangent to the e to the x and goes through the origin. First step, what would you do in trying to solve this?
Find the derivative, which is e to the x.
Okay, yes, but why? Like, to me, I need a picture to see what the hell's going on. Ben?
To find the slope of the derivative, the slope of the tangent line.
Okay, I need to find the slope of the tangent line and I need to find the slope of the curve. But really, so that I understand what's going on, I'm gonna draw this. Like, those of you who can just jump right in and be like, brute force through, cool, and my brain doesn't work that way, I need a picture. So I have e to the x, and I have a tangent line that hits the curve here, wherever that is. And the tangent line goes through here. Yeah? So I need the slope of the tangent line, and I need the derivative. And wherever this coordinate is, they need to be equal. Like, to me, I need the picture to see that that's what we're looking for. I don't know the numbers that are the coordinate, but I know variables. What is that coordinate in terms of variables? Yeah.
E to the x, comma y.
E to the x comma y.
It's like 5
No.
minus.
Well, y is e to the x.
The y is e to the x. Y is e to the x. So what is the x value? X. Okay. All right, so the tangent of, or the slope of the tangent line, just geometry. Andy, y minus y over x minus x. What do I get? Y minus y and x minus x.
Oh, it's just x and ex? Or
The y value?
e to the x over x.
And that's it, like e to the x minus the origin, so minus 0, over x minus 0. Okay, Lily, the derivative of e to the x?
E to the x.
You get the hard one, okay. That's e to the x. So the tangent line at whatever this x value is needs to equal the derivative at whatever that x value is. It's not written, but what number is under e to the x? 1. So I don't know, what is x? 1. Or you could go the long way and now dividing by e to the x everywhere, oh, x is 1. So this coordinate is 1 comma e. So the tangent line, the equation, y minus the y value equals slope times x. Technically, x minus the x value. So, x is the answer. Crazy tricky. So if, like, geometry is very, or geometry, calculus is very, very much geometry, and like it's visual. If you're doing all of these with no visuals, I find that hard. Like, some of them are crazy, like I have no idea what the graph looks like. I'll just do the derivative and analyze that. That's chapter 4. But this one, I can't do it without a picture. I don't know why I'm doing what I'm doing if I don't have the picture to show me. All right. Other things from anything in the homework? Natural log, regular log, log of stuff? No? Okay. Logarithmic differentiation. That's what we're doing today. Think I talked about this in here yesterday. We learned this derivative pattern yesterday, 3 to the x. Well, e to the stuff is e to the stuff, so 3 to the stuff is 3 to the stuff, and then you got to pay the exchange rate. That's that guy's derivative. This one that looks a lot the same, just the x and the 3 are in different places. Does that matter much? Oh yeah, a whole lot. Multiply by the power, lower the power. Here, cannot multiply by the power, lower the power. The base is moving and the exponent's moving. Moving target to a moving target. Do I apply this rule? Do I apply that rule? The answer is no. Just no. So when we have things that both of them are moving, there is this technique that we will use because it does good things for us. We're going to do natural log to both sides. And the reason we do that is we took something that was crazy and we made it product rule. And we scrolled it off the board. All right. Milo, derivative of the stuff on the left with respect to x.
Stuff on the left.
Yes, natural log of y.
Oh,
Doing the homework would have been a great idea. Or having notes from yesterday.
I have a lot of notes.
And you have math.
Is it natural log y times 2y dx?
Nope. Jeremy?
Is it 1 over y times 2y dx?
So the derivative of natural log of stuff is 1 over stuff times derivative of stuff. What's the derivative of y with respect to x?
dy dx.
dy dx. Okay, on this side, Sam, what's the derivative of that product?
So it's cosine x times 1 over x, sorry, 1 over x times, plus ln x times negative sine x.
Okay, then I gotta solve for, oh, I wrote it, okay, that I squirted the negative sign out front, okay. I'm being lazy and trying to not have to write things too many times. and here's another being lazy. I need to multiply both sides by y, but I don't want y in my final answer. Yoav, what was y equal to in the first place? All the way up here. So when you need to use logarithmic differentiation, or that log trick in the first place, it's not usually gonna end up being very pretty. But I could do the derivative. Yep.
Yeah, so that's the final answer?
Yeah, gross, isn't it? Like, I could distribute it out, but nothing's gonna combine, nothing, it's just ew. Yeah. Okay. Try x to the x. Do not multiply by the power and lower the power. That does not work. Any brave soul want to do it on the board? Ben?
I
No?
guess I can do it, I just don't know if I'm right.
Well, you know, live a little. So natural log of both sides, that is the right start. And he took the exponent down already. Derivative of the left is the same one as the problem we just did. 1 over y times implicit, or chain rule, whichever way you want to see it, dy dx. And now we have product rule, first times the derivative of the second, plus second times the derivative of the first. And then we need to get dy dx by itself.
Can I skip like the step?
Yep,
where-
like I did.
Yeah.
Just as long as you use your parentheses. Y is now known as x to the x.
Yep.
Okay, one quick thing.
Isn't x over x?
What is that?
Oh, it's 1, sorry. Yeah. Yeah.
1 plus ln x. That's it. Questions? Milo?
1.
So, do you have a question, or you're telling us that this is, that's a 1, yes. Okay, do we need to do these two, or do you have the idea? Okay, that looked, someone gave me a yes, we need to do these two. So, let's try that one first. Sin x to the x. So some of you have boards under your desk. When you get an answer, put it on the board. If you don't have a board under your desk. You do have one. Does everybody have a thing?
Right? Because Ellen of sign X, right?
Ellen, you guys have markers?
Yeah. You do 1 over sign X times
Wait, no, we need 1 over sign.
I don't think it's
With the
completely
derivative
simplified, but I
of
think we
That's-
are
that's-
almost
that's
there.
the derivative.
And that's what matters.
Wait, what's the restriction?
Oh, it's up right there. Never mind.
Oh,
X
yeah.
over sign X, but otherwise.
Yeah, X is X over sign X plus Ellen sign X.
Oh my goodness, our math has been There's not a single number in this math.
So I was doing my standard thing and out at dinner grading papers, while like little kids are running around and my neighbor's kid's like, what you doing? I'm like, grading math tests. And he's like, where are the numbers? He's like, Dad, I want to go to high school. This math doesn't have any numbers in it. And people are like, stay away from my child. Cool. So this is what these guys say. I saw different answers.
That's actually, I mean, same thing. We
It,
just did simplify it all the way.
I saw some different ways of writing the trig functions, which doesn't mean it's wrong. It could just be different. So 1 over y dy dx. First times the derivative of the second, derivative of that, times chain rule. So then it becomes y times x. If you still had cosine over sine, that's fine. Cotangent is also right. Natural log of sine x. So I agree with that one. There are different ways to have written it. Not that anyone would have done this, but I could have made it negative ln cosecant x, because bring the negative in as the exponent and flip it. Lily, it'll come up later. It's a thing. Sorry. Okay. And then, all right. So, this one, I don't need the logarithmic differentiation for the moving target things. However, I need to do log so it's possible. All right, so see if you guys can fight through this. Do log on both sides and do all the algebra of pulling the logs apart and then do the derivative.
Do you have to do log?
Okay, I tried doing, I'm good with math. I can do the power rule, I can do the quotient rule underneath, and then geez, then the chain rule with the product rule and yet another product rule, and then more power rule. Like, I got lost.
So don't.
There are, like, I will time you and you will be here tomorrow. But go ahead, the rest of us will be done. I highly recommend you use the log and log properties first. Go, Daniel, go. Do it the hard way.
Doing anything. To get rid of the fruit, or can we distribute that first?
Oh, what's the problem?
What does the log even do? What does the log do? Can we get rid of the root 5, like your base 5?
1/5 ln.
Yeah,
Oh, it's not like.
What does the log do?
Oh, I thought you meant like log base something.
No, just ln, both sides. So several steps is all just Algebra 2 or Pre-Cal, wherever you learn properties of logs.
Yeah, it's one over, that's what it's for. We know we can do.
So I don't know that I can bribe you with candy, but I have granola bars that are covered in chocolate, or trail mix, which has M&Ms in it. So whoever can give me an answer that is in some form correct.
We know, 'cause it's. Everything's just a one fit, we can just destroy the one fit. Two things times each other, and then it's like ln dash is on this.
Yes. Catching on. This is a lot.
Oh, yeah, well, you don't need to. No, I think she was doing the derivative of this massive. Just use quotient and
In product.
oh, she.
You see.
Are you,
This-
are you trying to do the long way?
Sides, and then we combine it
No,
with
we did
this to
not.
everything individually.
I mean,
I think we
when
barely
you
got
get
rid
to
of
your
anything. I think there's more than
percentage,
I know,
does
but
that
I think
make
there's still
any
more we
sense
can
inside?
get rid of the log.
Flip
We
that.
don't know how. Or I
I think
don't
it's
know.
plus.
Can I just raise our percent to E? Can I just raise it all to the E and then get rid of it?
Okay.
And it's just like,
Oh, you could say so.
oh yeah, then it's kind of the same thing. Oh, it doesn't. Because you can bring these to the front.
Just log with you without multiplication.
It's 5 is by 5.
And then that in parentheses.
So,
Anyone close to sharing an answer with me?
how simplified do you
Yeah, okay,
want
that's
this?
so much.
It doesn't have to be super simplified.
Oh, not that bad though, if you like.
I am not confident in my answer.
Now if I raise it to the E, it's
No, I'm just pretty sure.
I see what she meant.
Okay, well, stuff reduces.
So there's like 3 sets of parentheses.
What is underneath here?
Where do I take the derivative?
It's 1/5, and what's up top?
I think you're going to get
3 times 2x plus
Like, wait, if I raise it to the E, can you make it 5 y equals 4 times x minus 3
Then
plus
you can give me that. Your last
Because just simplify
You rearrange them because they're all like
Oh, we're supposed to.
And then the derivative of that is just one, so you don't have to.
Right.
Okay, so we have that.
Does this idea work?
You can't simplify it.
Yeah, oh, it'll
Raise it
simplify
to
out.
the E, is that legal?
I'm the keynote, so that's like the.
Show the work.
Where did he go?
Wait,
Like,
E here and then E on all those.
you can't do it individually.
Yeah, basically.
It's to the whole group.
Oh, to the whole thing.
1 plus, it's like 1 over x squared.
Doesn't distribute. It doesn't like just like if I do this whole this line times E, does it get E? I thought it did. It's just E to the entire thing. Here and then.
Division.
Any other way to do
Have a winner, chicken. You got two?
Different, like,
Can you factor out like an L in here?
Something.
Where are you holding? Like kill it.
Okay, now I'm
Okay, yeah.
Anyone else think they got it?
I don't know how
Did I
to
re-put them together?
do anything.
Just be the last word.
How much do we have?
Why don't you do 1 over 2x plus 5, all that cubed times,
So, stuff reduces, so don't leave these.
But now I just take the derivative. Now it's on addition.
What's your denominator? Is the denominator gone?
Yeah.
No.
She
Isn't that wrong?
Six.
Not the E step, but this part.
So is this still there or not? So, yeah. Oops. Are you like, did you fix it? Yeah. How much are you?
Because it's like, you just have to
Okay.
split up so you don't have to.
Yeah.
Yeah? Is that it?
I don't think I have it, but I think I'm on the right track.
I'm like really, I can afford that with those.
Take this giant
Okay.
thing.
Okay.
I don't know where that.
Okay, wait.
All right, so, lots of just, all of this, the red and the blue is just algebra. Just algebra 2 and pre-calc. Pull all the logs apart, do all the log rules. Like, first thing, bring that coefficient, that exponent down as a coefficient, then split everybody up. The added things were multiplied inside, the divided things become subtraction on the outside, and then I moved the coefficients down. And then very painfully, over there, the derivative, and then here, 4 times 1 over stuff, chain rule. 1 over stuff times chain rule. And then minus 3 over stuff times chain rule. So Constantine, I don't understand why you had stuff up top still, and like, you had x minus 3 to the third over x minus 3 to the fourth. 3 of them on the top cancel with 3 of them on the bottom, and you're left with just 1 on the bottom. I don't know how or why you're having bunches of them. Reduce, like what?
Yeah, I was trying to just like be the fastest, so.
Oh, okay. That's never a good idea.
Yeah, I know. That's why I
That's-
got the last part wrong.
Yeah, because you were super close.
Yeah, no.
And then the last thing is multiply by that big nasty y. Okay? You didn't tell me in time to get a product.
We didn't simplify it, but we got the
Okay.
version.
Okay.
Figure out the law.
Yeah. I mean, okay, this solidly not on the test on Thursday, no. But it's to just show you this technique made it doable versus Daniel, seriously, I did try it and it was a long time and a lot of paper, and after a while, it was so huge. It was just so many parentheses.
So what would you say are like the best indicators for using this technique versus like just the rules?
Okay, so for what you guys need to do, the way to recognize, oh, come on, moving target to a moving target. Ones where it's useful, but not technically needed. I'm not gonna ask you those. Those are like grad school when you're really, like, this is a real world problem and you're mapping LiDAR data of the stars down on like this curvature thing onto something flat and you'll need weird stuff. That's a problem 7 years from now.
So you just use the rules when it's like x to a constant or a constant.
Moving target
instead
to a
of-
moving target. If either thing is a constant,
Right.
3 to
That
the
makes
x,
sense.
I have a different rule for that. X to the 3, I have a different rule to that.
Yeah.
X to the sine x,
Yeah.
I need to bring that moving target exponent down. So. So we still have 5-6 minutes. So these are kinds of things that, like, can you do these kinds of derivatives? Stuff like this can be on the test. Can you do those?
It's like the basics.
The basics, well?
Because you could just crush it there, because the derivative's like 32.
I sing a little tune. I don't know why.
What was the growl for?
Oh, no, we have to break it up first.
With the baddest. Yeah, that's good.
Okay. Okay. I am blaming Annika. She's going to pick a card. And whatever card she picks is that person. You picked yourself, and I'm not kidding. Look, you are the 8 of clubs, right there. You get to do the first one. The second one. So go ahead, put it up. Yeah, doesn't need to be done. Second one, Daniel, can you put the second one up? If we have time, Andy, you would get the third one, but you gotta wait for Daniel to finish the second one.
I just finished the third one on the book, so I.
So do number 2. And the last problem is the last person in the alphabet, which is Ben. Just so you know, you're all assigned to a card. Sam, you're the 5 of diamonds. Evelyn, you're the 6 of clubs.
What's the best card, would you say?
You know, whichever one.
Who's the ace of spades?
The Ace of Spades is group 1. Spades are groups 1, 2, 3, 4, 5, 6, 7. So it goes through clubs, then diamonds, then hearts. And spades is reserved for the group numbers. Daniel, what are you waiting for?
Can I do that at the same time?
Yeah. You can write at the same time. It's the cool thing. You can have 10 little fingers on there. So Annika's was kind of hard because she could not do a divide and conquer. She had to actually do quotient rule. Bottom times the derivative of the top minus top times the derivative of the bottom over the bottom squared. And she gets all of that stuff. Yeah. Felipe, the bell did not ring, sir. And Andy is doing a divide and conquer, splitting it up before he does the derivative, because that's easier. Oh, I would have reduced before trying to do that.
Oh, yes.
Wait, I could probably just whip it.
Right. Well, thank you.
Thumbs up.
The idea was there.